demonstrate access to the location of the first character by simply using 0 offset from that location. And the following does the same thing, basically using address, any expression that provides memory address which already remembers the type of objects that it's trying to access. We can use either square brackets or index or subscript operator providing the offset from that location. In our case, offset is 0, meaning just use this specific location. Or we can use a shorter form of this, is location with an asterisk in front of it. And it should look already familiar to you because this is a dereference operator that we discussed in previous video. So essentially these two statements are exactly alike. They're doing the same thing, and both of these statements will be printing character H. Second name for dereference operator is indirection operator. Now the B programming language, which is a predecessor of C, was developed by Ken Thompson at Bell Labs, and it supported this notation, and it also supported dereference operator in its syntax. And it's also interesting that when you use an open source compiler and compile your code without specifying a name for the output file, it will generate A out, and it goes back to the history of B, where B generated directly an assembly program, and assembler would produce an executable. And this is why A.out stands for assembler output. C programming language kept most of B syntax, but added specific data types to the language. When we create a variable and give it a name, like this price variable on my screen, envision that we have a computer memory that has specific location where this variable gets allocated. What's important to know that once created, a variable is never relocated. It is never moving to any other place, and its address is a perfectly good identifier, a unique property that this variable has. And naturally, when dealing with memory locations, it's very simple to go to any named object and say, what is your address? So ampersand operator returns the address of that variable. Of course, when it returns the address, we have to be able to store it in a pointer variable, and this is our pointer variable example, and it needs to match its type, needs to match exactly the type of the original object. So basically we say that the location is a location or address of a double, which is price in our case. So ampersand returns the address. And then once again I'm demonstrating how we could use both subscript notation or dereference operator right here. Both of these statements are identical to print this value on our screen. Pointer itself is a data type, so this variable location, which is a pointer variable, has a type pointer to a double. So that's the type of this variable, and location itself is a variable. And dereference operator once again allows us to access this location, store new values there, and also be able to use dereference operator to extract the value from that location and give it to other variables. So dereference operator effectively unlocks the memory cell, provides you access to that memory cell. Dennis Ritchie is the creator of the C programming language. It dates back to early 1970s, and most of the B syntax was preserved by C. One other significant event in the history of C is that the Unix operating system, rewritten in C in 1973, and ported Unix to the next model of Digital Equipment Corporation machines, PDP-11 model. Also, very important text, the C programming language, which is de facto standard source of information about C syntax and all of its rules, is also dating back to about this time, so it's dating back to 1978. Function parameters naturally can be pointers. So here we take a pointer as a parameter. This is PTR is a variable which is a pointer to a double, and this of course is the parameter of a function named takePointer. An older syntax, or similar older syntax, is this, and this is now considered to be an older version of pointer declaration as a function parameter. Here we make an attempt to just go through various uses of pointers and demonstrate how they can be applied in different situations and what are the possibilities to use them.